AM amplitude modulation, we had the modulated signal equation as AC 1 plus Ka m of t and then cos 2 pi fct, cos 2 pi fct. If we take Dsbsc modulated signal, we had the equation AMAC by 2 cos 2 pi Fm plus Fc into T, Fm plus Fc into T plus AMAC by 2 cos 2 pi Fc minus Fm. Fc will be higher value, so I will write Fc minus Fm into T. This is multi-tone modulation. This is multi-tone modulation. In single tone, S of t equal to AC cos 2 pi fct followed by AC mu by 2 cos 2 pi fc plus fm into t plus AC mu by 2 cos 2 pi fc minus fm into t. This is about single tone modulation. Single tone modulation. And if we see in AM, this is the carrier component. This is the carrier component. So plus means this is upper sideband component, Fc plus Fm, upper sideband component. Fc minus Fm, this is lower sideband component. In Dsbsc, we don't have any carrier component. This is upper sideband component and this is lower sideband component. Lower sideband component. And coming to SSB, only one sideband will be present in SSB. So S of t can be AMAC by 2 cos 2 pi Fc plus Fm into T, only upper sideband, only upper sideband. Otherwise, S of t equal to AMAC by 2 cos 2 pi Fc minus Fm into T. If upper sideband is there, Fc plus Fm. If lower sideband alone is considered, Fc minus Fm. So you can also expand this cos of A plus B. This is cos of A plus B. So what we can do, you can expand cos A cos B minus sin A sin B like that. Here also cos A cos B plus sin A sin B like that we can expand. So I don't want to write too many equations. So just I will wind up with this. This is USB or LSB will be present, or LSB will be present. And if we remember the power equations in AM, total power equation in AM, it is carrier power into 1 plus mu square by 2, which is nothing but PC, then PC mu square by 4, PC mu square by 4, and PC means carrier component. This is the total power. This is carrier component. This is upper sideband power. This is lower sideband power. Okay, this is total power in AM. Total power in AM. And coming to Dsbsc, carrier can be removed. Carrier power can be removed. This is about AM, the total power. Next, we are moving to Dsbsc. We are moving to double sideband suppressed carrier. And the total power here is AC square, AM square divided by 4, divided by 8. Total power is 4. Okay, so just I will write 4 and then elaborate it for upper sideband, lower sideband separately. I will try to write it 4 first. This is the total power, AC square AM square by 4. and further it can be written as AC square AM square by 8 plus AC square AM square by 8. And if we take one term as lower sideband power, other term will be upper sideband. This is upper sideband, this is lower sideband power. We have also done problems in Dsbsc. We have also done problems in Dsbsc where we calculated the total power. So you can see here the total power AC square AM square by 4. AC square AM square by 4. The heights will be AC AM by 4, AC AM by 4 like that. Okay. And this is about the Dsbsc total power AC square AM square by 4. Because we have upper sideband, lower sideband, it is AC square AM square by 8, AC square AM square by 8. This is lower sideband and upper sideband power in Dsbsc. Now I am going to SSB. I am going to SSB. Only one of the power can be taken. One power can be taken. So either upper sideband or lower sideband. So the total power is AC square AM square by 8. Whether it is upper sideband or lower sideband, total power in SSB is AC square AM square by 8. Okay. So this power equations are important in this complete discussion. You need not remember the single tone, multi-tone, the entire modulated S of T equations not required. In this entire discussion, S of T equations you need not remember, but the power equations are important. Power equations are important. Okay, so I will put important this power equations, total power in AM, total power in Dsbsc, total power in SSB, whether it is lower sideband or upper sideband. Okay, so this is about the power calculations and the equations comparatively in AM, Dsbsc, SSB. Now, let me take an example. Let me take an example. In AM, if the total power is 50 watts, total power is 50 watts, and modulation index is 1 by root 2, efficiency, modulation efficiency is 20%, modulation efficiency is 20%. Okay, then what about the carrier power, sideband power, lower sideband, upper sideband power? So generally we know that efficiency percentage and sideband power percentage are equal, so it will be 20%. So total power is nothing but carrier power plus sideband power. If total power is 100%, sideband already 20 in the previous line, now the carrier power will be 80. Carrier power will be 80% of the total. 80% of the total. These are the details relatively we can analyze. Now, this total power can be taken as 80% is 40 and 20% is 10 watts. 10 watts. So this I am taking as sideband power. This I am taking as carrier power. Sideband power, carrier power. And further, this total power can be written as 5 plus 5, and this is carrier power, this is lower sideband power, this is upper sideband power. Based on this analysis, this relative, we know the relative details from the efficiency. We are identifying sideband power also the same 20%. So total power will be always 100%. If sideband is 20, then carrier power will be 80%. And here we are assuming the total power is 50. Based on that, we are splitting what is the carrier power and sideband power. Okay. Now, in Dsbsc, total power is nothing but sideband power only, lower plus upper. Carrier is removed. So the total power is nothing but 5 plus 5, which is 10. And hence, power saving in Dsbsc, power saving in Dsbsc is nothing but total power, okay, in AM, total power in AM minus what is the power in Dsbsc, divided by what is the power in AM. So we had 50, Dsbsc only 10, and the total power is 15 AM. This is 40 by 50 and 4 by 5 or 0.8. In percentage, this is 80%. This is 80%. Okay. So power saving in Dsbsc is 80%. Power saving in Dsbsc is 80% compared to AM. Compared to AM. 80% power is saved by suppressing the carrier. By suppressing the carrier. Now I will take SSB. In SSB, we will have total power is only one power, either upper sideband or lower sideband, either upper sideband or lower sideband. So the total power is only 5 watts. Total power is only 5 watts. So from here, if we analyze what is the power saving in SSB, power saving in SSB compared to AM, compared to AM. So total power in AM minus total power in SSB by total power in AM. So SSB AM it is 50, SSB only 5, AM it is 50. So 45 divided by 50 and it is 9 by 10. In percentage it is 90%. 90% power can be saved if carrier is suppressed and one sideband also suppressed. Power saving in SSB compared to AM, it is 90%. Okay, this is the analysis. This is very, very important. Power saving in Dsbsc is 80% and power saving in SSB is 90% comparative to AM. Okay. So this we are taking a numerical value 50 watts as the power in AM and doing some analysis to find out how efficient the Dsbsc and SSB are compared to AM. Okay. So in Dsbsc